Hello, in this video we're going to be talking about blood tissue and bone tissue. Let's not waste any of your time. Let's get right to it. Now we're talking bone tissue. We want to talk about the individual components of that. Obviously with bone, you're not going to have that real fluid type environment, more of a solid structure, but we do want to talk about the members of the bone tissue. We're going to start at the bottom of my list. I didn't really put these in a good order as far as the pathway of talking about them. But that's the osteogenic cells. That's the stem cells that are located within bone. They can give rise to the osteoblast. I referred to earlier the suffix of blast. These are cells that make the new material for whatever the tissue might be. In this case, it'd be bone. So an osteoblast cell is going to be a cell that forms new bone. Okay. The opposite of that would be the clast, the osteoclast. If blast makes cells, then the clast is going to be the opposite, and that's break it down. And so the osteoclast, we're not talking about breaking it apart by any means. You can't want that. But we're talking about like sanding it, cleaning up rough edges. So it's breaking down the bone material, not necessarily the whole bone itself. So if you get your little hairline fracture and something, and in the process of that bone repairing itself, it isn't a real smooth surface. Then the osteoclast can come in and kind of break that down and kind of smooth that out so it's not rubbing against muscle or any other tissue that might be irritated. Okay, an osteocyte is an actual bone cell, and osteocytes are come out of osteoblast that reach a certain level of maturity and convert to osteocytes, which means they're no longer making new material. They're now more of a traditional cell process. And the last one, the osteon, that's the bone itself. That's kind of like the finished product. So going from the stem cells out to the making, to the being, and to the breaking down of bone. Now the opposite of that would be like blood, which would be very watery surface. It's called the plasma. And you can, like when you donate plasma, you can donate blood. That's two different things that they're after. Obviously the blood, they're after the actual cells themselves, and they're concerned with the A, B, B, O type of scenario, where if you're dealing with just plasma, that's just the fluid, watery portion of that. And blood tissue is going to have a lot of stuff in it. I mean, you got your erythrocytes, your red blood cells, your leukocytes, your white blood cells. But then you've got all your immune system stuff, the big warrior macrophages that are just wandering around looking for any foreign material and can engulf that, and using their digestive enzymes and your lysosomes and your vesicles take care of that material. But you've also got all the phils, the neutrophils, the basophils, the monocytes, the eosinophils, all those immune system components that have a kind of a particular item they're looking for or thing they're looking for, and once they find those, again, they'll take care of that. Well, that's our video over bone tissue and blood tissue. When we come back together next time, we'll be talking about muscle tissue. We'll see you then.